We're ready for section 7.5. Now that we've learned how to measure angles, we are going to look at different angle pairs. All right? We want to be able to identify and use different types of angle pairs. And so I have 4 definitions right off the bat here. The first one is adjacent angles. Adjacent angles are coplanar. They have a common side and a common vertex. And they have no common interior points, which is to say they do not overlap at all. All right? Over here I have an example of adjacent angles. Adjacent really just means next to. So like they share a common side, and they share the same vertex, but then they don't overlap at all, and the other 2 sides, go in opposite directions. That is adjacent angles, angles that sit next to each other and share a common side. Next up, we have vertical angles. Vertical angles are 2 angles whose sides are made by opposite rays. To be honest with you, I don't like this definition. I think it's a little bit confusing. Basically, vertical angles are made when 2 lines cross, and they're the angles that sit opposite each other. So angle 1 and angle 2 are vertical angles. They're made by crossing lines, and they're the angles that sit across from each other. And angle 3 and angle 4 would also be vertical angles from each other. Our third definition is complementary angles. You probably have heard this one before. Complementary angles. Those are 2 angles whose measures have a sum of 90. So that could be 2 angles like these that sit next to each other, and together they add up to 90. Or it could be just 2 separate angles like over here. 47 and 43 adds up to 90, so we say that those angles are complements of each other, or they are complementary. And then last up, we have supplementary angles. Supplementary angles are 2 angles whose measures have a sum of 180. So here's an example of 2 angles whose sum is 180 because they make a straight line. Or again, they don't have to sit next to each other. We could just have these 2 separate angles here, 137 and 43. They add up to 180 as well, so angle B and angle C. Therefore, they are supplementary, or they are supplements of each other. One way, by the way, to keep that straight is, a 90-degree angle is sometimes called a right angle, and complimenting somebody is the right thing to do. Complements add up to 90 because complements is the right thing to do, and 90 degrees is a right angle, in case you have trouble remembering which is which. All right, so we are going to use the diagram at the right to determine the statement is true or false. You might want to stop the video and see if you can do these on your own first, but you can also just watch as I do it. So it says, let's see, use the diagram at the right to determine if the statement is true or false. Explain. Angle AFE, and CFD, are vertical angles. Well, AFE is here, CFD is here. They are made by 2 lines crossing, so they are vertical angles. This is true. If I had to explain, I'd say something like made by two crossing lines and, you know, sit across from each other, something like that. I really don't like the actual geometric definition that well. Two angles whose angles are made by opposite rays. All right, the next one, we've got angle BFC. So BFC is this angle, and DFE is this angle. Those are supplementary. Well, they're only supplementary if they add up to 180, and 118 plus 28 does not add up to 180, so that is false. Those angles are not supplementary. And our last example, angle BFD. BFD would be this angle. And angle AFB, let's do that one in green. AFB would be this angle, are adjacent angles. Well, they sit next to each other. They share the common side down the middle. So yes, they are adjacent angles. True. Share a common side. Number 2, name an angle or angles in the diagram described by each of the following. Use the figure at the right. An angle complementary to EOD. Well, here's EOD. So I need an angle that with that one adds up to 90. What I notice here is that since this is 90 degrees here, then that means this whole thing must be 90 degrees also. So therefore, this angle right here must add up to 90 with angle EOD. So I would say that angle DOC would be the angle I want that is complementary to EOD. It would equal 30 degrees, by the way. Next up, I need a pair of vertical angles. So to get a pair of vertical angles, I'm going to draw my two lines here. And I've got choices. Either I can use this angle and this angle. So that would be angle AOB and angle DOC. That would be those two. Or I could use these two, angle BOC and this one over here, angle AOD. And those are my pairs of vertical angles. All right. Next set of definitions or concepts is there are some relationships you can assume to be true from a diagram. All right, assume to be true from a diagram that has no marks or measures. And there are other relationships you cannot assume directly. Things that you can assume. If angles look like they're adjacent, they're adjacent. If angles look like they're adjacent and together they look like they add up to 180, you know, like this, these two angles, because the outsides make a straight line, you can assume it's true. They're not trying to trick you, and that line is actually 179.8 degrees. You can assume it is a straight line, 180 degrees. And when angles look like they're vertical angles, you can assume they are vertical angles. Again, they're not trying to trick you by having a line get to here and go a little bit down in shape. You can assume if it looks like a line, it's a line. Things you cannot assume. You cannot assume that angles or segments are congruent. So even, well, let me go to the next one. You cannot assume an angle is a right angle. So even if it looks like a right angle, it is not necessarily a right angle. It might be 89 degrees. You can't assume it's a right angle unless it says it's a right angle or it's got the little square symbol in it. And if just because angles look congruent doesn't mean they are congruent. You can't assume it unless they are marked equal. And you cannot assume angles are complementary unless they're marked complementary, or some other marking that shows they add up to 90 degrees. All right, so I have an example here, example 3, that uses these statements. So it says, can you make each conclusion from the information in the diagram? Can you assume that TW, that would be this segment, is congruent to VW, this segment? And the answer is yes, you can assume it because they are marked with little tick marks. The tick marks show that they are congruent. So because it's marked, you can say it's true. Can you assume that angle TWQ is a right angle? Well, it looks like a right angle, but it's not marked to be a right angle, so the answer there is no, you cannot assume it. It's not marked. Can you assume that segment PW, that would be this segment, is congruent to segment WQ? Well, I have to admit they look like they're equal, but again, you cannot assume it because it is not marked. Maybe they are a little bit off. And last up, can you assume that segment TV bisects segment PQ? Well, the only way it bisects PQ is if this point right here is the middle of P and Q. And since PQ is not marked equal, we cannot assume that, that W is the midpoint between P and Q. All right? We're ready to move on. All right, next definition. Our next definition is called a linear pair. And that is a pair of angles whose non-common sides are opposite rays. The opposite rays, of course, form a straight angle or a straight line. So, a linear pair would be, they would share a side, that would be the side they share, and the other, the non-common side would be opposite rays. So there's one ray, there's the other ray, those are opposite rays. That makes this a linear pair, or a pair of angles that form a line, linear. All right, and the next one is the linear pair postulate. The linear pair postulate says if two angles form a linear pair, then they are supplementary, or they add to 180, right? Okay, don't confuse the definition of a linear pair with the linear pair postulate, right? The linear pair postulate already assumes you have a linear pair, and if you do, it means they are supplementary. So let's look at example 4. Example 4 says, name two angles that form a linear pair in the diagram at the right. Well, there are a couple choices, but I'm going to use this angle, which would be angle LMQ, and this angle, angle QMN. Together, they share a common side, and their non-common sides make a straight line, therefore a linear pair. Example 5 says, angle ADB and BDC are a linear pair. So that means these add up to 180, right? Well, the measure of angle ADB is 3x plus 14. And BDC is 5x minus 2. What are the measure of angle ADB and the measure of angle BDC? Well, because they're a linear pair, I know they add up to 180. So 3x plus 14 plus 5x minus 2 is going to add up to 180. Or 8x plus 12 is going to add up to 180. And if I subtract 12, I get 168. And if I divide by 8, I get x is 21. Therefore, angle ADB is 3 times 21 plus 14, or 63 plus 14, 77 degrees. Uh-oh. And angle BDC is 5 times 21 minus 2, or 105 minus 2, or 103. And I have my two angles. And last up, the last definition is angle bisector. That is a ray that divides an angle into two congruent angles. So if you know that a ray bisects an angle, it means it splits these two parts into equal measures. So that's really what it says there, right? Let's do the example and be done. It says that ray KM bisects angle JKL. That might look like this. Here's J, K, L. That's the angle. And then I've got ray KM. So that might look like this. And I've got the bisector. This equals this. It says if JKL, well, that's the whole thing. If the whole thing is 72 degrees, what is the measure of angle JKM? This half. So I know that the whole thing is 72, and these parts are equal, so 72 divided by 2 is 36. Each half is 36, so this angle must be 36. And last up, I have that ray GH, that's this ray down the middle. It looks like my H got cut off. So there we go. Ray GH bisects angle FGI. First, they want me to solve for x. Well, since that is the bisector, it means that this half and this half are equal, or this measurement and this measurement are equal. So I can say that 3x minus 3 must equal 4x minus 14. And if I solve that, I get x equals 11. So I can find the measure of HGI, that's this bottom angle down here, by plugging in 11 for x. 4 times 11 minus 14, or 44 minus 14, or 30 degrees. And I don't really need to find FGI, because FGI is going to be the same thing. It's also going to be 30 degrees, because that whole thing got bisected. Uh-oh, I said that wrong. FGI is the whole thing, so that would be, if each half is 30 degrees, then FGI would be 2 times 30 degrees, or 60 degrees. There we go. Good luck.